Hello. Let me introduce an alternative approach for velocity metrics calculation. But first of all, what exactly the velocity metric is? Long story short, it's just an aggregation of data for the particular period of time. Like a number of unique credit card numbers used in bookings by a single person for the last 30 days. For online metrics calculation, our service should be very fast. Metrics should be always up to date and new metrics should be easily configured. What is Cassandra? Apache Cassandra is a massively scalable open source NoSQL database. Cassandra is perfect for managing large amounts of data across multiple data centers and a cloud. Cassandra provides continuous availability, linear scalability, and operational simplicity across many commodity servers with no single point of failure. It has powerful data model design for maximum flexibility and fast response times. How does Cassandra work? Cassandra has a masterless architecture, meaning all nodes are the same. Cassandra provides automatic data distribution across all nodes that participate in a ring cluster. There is nothing programmatic that a developer needs to do to distribute data, because data is transparently partitioned across all nodes in a cluster. Cassandra also provides customizable replication, storing redundant copies of data across nodes that participate in a Cassandra ring. This means that, if any node in a cluster goes down, one or more copies of that node data is still available on other machines in the cluster. Replication can be configured to work across one data center, many data centers, and multiple cloud availability zones. Cassandra supplies linear scalability, meaning that capacity may be easily added simply by adding new nodes online. For example, if 2 nodes can handle 100,000 operations per second, 4 nodes will support 200,000, and 8 nodes will tackle 400. Let's have a look at our data structure. So, we have a composite primary key, consisting of fixed metric type, and its value. Our columns are represented by clustering key of related metric type and timestamp. The column value is just a related metric data. Using that structure for keeping data, we can easily retrieve data for custom period of time for the particular pair of attributes. Then, we calculating metric value based on the particular configuration and store it in velocity metrics table. It has the same partition key, aggregation type instead of timestamp in the clustering key. The column value is the result of data aggregation. Let's add some more data and have a look what changed. Let's say that there will be a new credit card number with different amount. As you can see, we still can get data for our email with a single request. Metrics have also been updated. Let's have a look. How does it work in our simple UI application? We have our metrics configuration stored in MongoDB. Let's add a new metric. Let it be form of payment. Then, we'll put a data aggregation configuration for the different metric that we have already added. Let it be a number of purchases for the last 30 days. It's a default period in milliseconds on the right. But no, let it be a total amount. And total number of credit cards for the same period. Saving our changes. After that, we are going to link one more existing metric with our form of payment. Email, for example. Searching for form of payment. Let it be unique number of them. Okay, that's done. Then, we are going to check our changes with some test data. As you can see, here we have all the available metrics as separate fields. Let's fill such fields like email. Our new form of payment. Credit card number. And purchase amount. Then, send our data to web service. There is no response yet. But new metrics have been saved. Let's have a look. As we can see, here are the unique count of form of payments per email, and both new metrics per form of payment as well. Let's check it again, sending different email. The same credit card number. Some purchase amount. And our Visa form of payment. Update. As you can see, here are the metrics saved on previous step. Because the new metrics are being updated asynchronously. Check it again, and we see current metrics. So, it's time to make some conclusion. Yes, it's really fast. In less than 10 milliseconds we can get the list of metrics of particular configuration. Cassandra provides a mechanism for data expiration. So we don't need to care about old data removing. Velocity service automatically saves all the incoming data. So we have the whole matrix of attributes to build new velocity metrics based on it. To add new attribute, just start sending it to velocity service. But this approach also has some drawbacks. Only one-on-one metrics support right now. That means, if we need to make metric of different credit card numbers of type Visa by some particular email, we'll need to create additional table for indexing. Or use complex primary key, like email plus card type. The second cons is that new metrics are available only for the list of data that was already sent to velocity service. To add new metric for a brand new attribute we need to collect data first. Or we'll need to add some historical data population mechanism based on Storm Engine or something. So that's all for now. Next time, we'll have a look at RedisDB approach and flexible mechanism of multiple primary metrics filtering. Thank you for watching.